Okay, Assalamualaikum class. We will continue to the lab 4, arithmetic instructions, multiplication and division. So in this lab, we will have procedure 1, mul instruction, and then we have procedure 2, mul instruction, and then procedure 3, we have div instruction. And the last one, we have div instruction. So we will have 4 procedures. Okay, as usual, you have to predict the output, and then you can check with the simulator. So for the procedure 1, I will show you how to do it, and the rest you have to do by yourself. Okay, you can get the lab report format with this given link. Okay, I give you a slight different from previous lab, because here, as you can see, the instruction, I don't start with the origin 100H, because I want to show you what happens if we don't write origin 100H. So we will look at later. Okay, now we have to do this first procedure without looking the simulator yet. Okay, no need to use the simulator yet. We just do the result. Okay. Okay, this is our instruction. And then we have to expect the results. And then we can check the result with the simulation. Okay, the yellow one is the change. Okay, is the change for the data inside the registers. Okay, so for the first instruction, we have instruction move AL. So AL will be affected, and then we have second instruction move BL. So BL will be affected. And then we have instruction multiplication. So because we do the byte between BL and AL. BL and AL, and the result will be saved in AL or AX. And then we move AX, so this AX will be changed. And then we have BH, move BH will be changed. Mul, again we use the same instruction, so AX will be affected. And then we have move AX, so same AX will be affected. And then we move CX, so CX will be affected. And then mul CX. So now this is different. We are not doing the byte size, so we do the CX. CX is a 16-bit, so we will do the 16-bit multiply with the 16-bit, so the answer will be in DX and AX. And then we move AX, so AX will be affected. And the last one, same value. var1, if you refer to your instruction, it is in word size, so we do the word size multiplication. So it will change, the result will be changed in DX and AX. Okay, now we have to expect the result. Okay, so also CFN overflow flag for the mul instruction mul, it will be changed depend on the result. Mul, and another one we have mul, and the last one we have mul. Okay, so what is our var1? var1 is define word 250H. So I just put 250. And then move AL20. So change this decimal value. Okay, decimal value 20, hexa 14. 14. And then BL, we have 0, 3. And then we have to multiply BL and AL. 14 multiply with 3. Okay, 14 multiply with 3. So we get 3C. 3C, 0, 0, 0, 0, 3C. Okay, and then move AX. Okay, we have 0, 0, 5, 3. And then move BH 4, 4, 0, 4. And then we have to multiply BH with AL. 53 multiply with 0, 4. 53 multiply with 4. And then we have 1, 4, C. Okay, 1, 4, C. Okay, and then look at here. So when the result, high result 0, so it must be 0. When the high result not 0, it must get 1. Okay, and then we have AX 100, 0, 1, 0, 0. And then CX is 4, 0, 0, 0, 4. Okay, then we have instruction mul CX. So we have to do the multiplication between AX and CX. Okay, 104. And then we can get 400 lah. And don't forget the value must be start with the X. 0, 0, 0, 0. And then 0, 4, 0, 0. So this the value of the multiplication. And then look at the CF and OF. We have to refer to this value. The higher value. I put the color. Same with multiply here and multiply here. It will look at 0, 1. And this one, it will look at 0, 0 here. So 0, 0, that's why you get 0. This is the value, so you get 1 here. Okay, so this one, we got 0. Because the value is 0. And then next instruction, AX will be equal to 70. Okay, and then our var maintain the value 250, and then we have to multiply with 70. Okay, 250 we multiply with 70, and then we get 10300. So 1 will be saved in dx, and 0300 will be saved in ax. Then we have the value 0300 here, and this one is 0001. Okay, sorry class, for the previous video, to determine CF and OF for the instruction that involve 32-bit multiplication. Okay, dx and ax as the result. So we have to refer to the highest. So the highest must be dx. So we have to refer to dx. If we compare to the 16-bit 16-bit result of the multiplication, we just have to refer only to the AH only. Okay, same with this one, just refer to the AH only. So this AH equal to 0, then your CF and AF also 0. And when you have value here, AH has value, so your CF and OF must be equal to 1. While here, we have to refer to DX. So our DX is 0, so then CF and OF also 0. However, for the last instruction, the value is DX. The DX value is 0, 0, 0, 1. It has a value, it is not 0, so CF and OF must be equal to 1. So the rest, you can write down the value, the latest value. Zero, 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 zero. Maintain the latest value. Then this one 0, 3. Okay, finally, this is our final results, okay, that we expect from the instruction. So, because we know the instructions all about, so we can get the result for each instruction. So, this is a final result. So, you can check with this value, okay, this table. Okay, then we can proceed to the simulator.